Okay, so I think we are recorded. No, we are already recorded. So good day to all EEA 123 students. So we will discuss on the supply and distribution side, the introductory and power distribution networks. And on our first part, we will discuss a little bit of protection and how you protect a power distribution. Although I usually discuss this on my power system protection class, I give a little bit of information kahit paano for our operation and how you protect your primary distribution network. So today we will discuss some preliminaries before we move forward to the calculation parts. So there are some calculation parts in this part 3. Okay, and it is divided into 4 lecture series. So let's move on, so that we can conserve our time. Okay, let's have the next slide. So again, this is what we have discussed so far, yung power system scheme. That distribution includes any electric parts of an electricity network, utility network between bulk sources and the consumer service entrance. So yan ang sinasabi niya na distribution. Now, this is also the same thing when we discuss yung secondary transmission. So from there, from the secondary distribution, we anticipate yung mga loop, yung mga network natin, which is yung subtransmission natin. And then from this subtransmission network, we already going forward to our primary distribution. And from the primary distribution, papunta na yan sa secondary, right? To secondary distribution. Now, ito yung sinasabi niya rito, yung distribution includes the parts of an electricity network utility kasi the subtransmission here can be modeled as your primary utility. Diba? Utility. Grid or grid. Now, from the utility there, papunta na ka na sa distribution mo, syempre, you need your substation here, which constitute your primary distribution, and then papunta na sa secondary. Now, yung utility or grid mo rito, it is modeled in an MVA short circuit so that you can get the Thevenin's former reactance, yung sinasabi natin XTH former by dividing the MVA base by the MVA short circuit. Now, from there, from that model, pababa, yan na yung tinatawag nating distribution networks. Now, we can anticipate on the power distribution network topic. We can also discuss subtransmission, and we can also discuss underground cables. Now, the design here is mainly based on the first few parts, mainly based from what we have discussed on DC distribution and AC distribution, yung tinatawag nating distributors, if you can still recall. So, again, from the distributors, we can now model, okay, the area or the volume of the conductor material that you want to use for your design. Depends on the standards and some tables that we can anticipate in the next few slides. Okay, now from there, from the distribution network, also distribution systems, okay, based from the introductory here is a portion of the utility system as mentioned between the distribution networks or distribution substations rather and the consumer service entrance. So kailangan we need to have your utility syempre on our distribution here, di ba? Meralco tayo eh. Since we are in Metro Manila eh. Kaya nga decentralized pagdating na sa distribution. Now, kapag ibang lugar naman, kanya, Pangasinan Electric Company. So, Pagelco naman ang tawag sa kanya. Iligan Electric Company. So, Ilelco naman ang tawag sa kanya. So, from there are different distribution networks. So, different circuits, different laterals. So, depends on the load. So, syempre, here in Metro Manila, you already know, this highly dense, yung population natin, highly dense. So, we can anticipate many laterals and distributors. But in this case, in our in Meralco, that will be our main utility, syempre, because separate dapat yan sa transmission. Yung transmission natin centralized, right? That is being maintained by NGCP, National Grid Corporation of the Philippines. But anyway, let's move forward to the discussion part. So the parts of a typical distribution network, well, this circuit is based on US. So as you can see, the sub-transmission circuits nila, they have a vast kilovolt levels there. So different levels from 12.47 sub-transmission na yan, to 345. So may 115 pa yan, 34.5, 13.8, etc. So those are sub-transmission circuit with the voltage ratings stated here. And then distribution substation, which converts, as usual, as we have discussed, your substations from lower primary voltage with a local distributor, which is from our side, Meralco. Then from there, you have your primary circuits, which is a 3-phase forward with a 50 kVA rating of a 3-phase industrial customer. So kailangan meron ka pa ring primary distribution. And they are usually from the range of 4.16 to 34.5, supplying a load with a well-defined geographic area. So ito yung sinasabi natin in terms of a single line diagram. You have your bulk source here and your sub-transmission networks, which is yung po naka-loop, naka-multi-loop, may mga interconnectors, etc. Now, here you have your substations. So these are transformers which supplies different circuits. So may mga feeder circuits yan. So if you can still recall, yung dinidiscuss natin, from the diversity factor, di ba? We have your main substation, and then you have your feeder laterals. And then we need to get yung diversity factor here, which is we already know how to deal with it. If you're your maximum demands, MD1, MD2, hanggang MDN. So get the summation of those and then divide by the simultaneous MD. Simultaneous maximum demand. So your diversity factor summation of all your maximum demands all over your MD, o simultaneous maximum demand from your substation. So ito rin yan, yung mga yan. One part lang siya. Because as you can see, different distributors, but you have a centralized sub-transmission network. So that is a typical. And then your power source, this is your generating plants, right? So again, it can be divided, if you have your primary feeders, and then your secondary feeders afterwards. So ayan. So ganyan yung niyan. Ganyan yung single line diagram. But if you want to know the specific single line diagram and then the protective devices that is incorporated on each section and laterals, we can discuss this more in the next few slides, or we can clear this up moving forward. So this is the more comprehensive or specific doon sa part na dinidiscuss natin. Ito, okay? So this is one part of it. You have your substation buses. So ito na yon. And then you have your transformer. May transformer dyan, definitely. Hindi ko na pala pinakita din. May transformer sa taas yan. So parang ganyan yan. Ayan. Tapos sabay bus na yan. And then from there, you have your main circuit breaker, your MCB, from the secondaries. And then as you can see, as we move downstream, pababa, may napapansin kayo dito, may mga different circuits. Ang tawag dito, guys, is a section. At ang tawag naman doon sa mga nag-branch out, yung branches, is a lateral. Okay? And then every lateral here, may mga ano pa siya, no? Pababa pa siya from your distribution network. Kaya napansin niyo magiging 240 pa ito, no? From a, for example, 400 volt, okay, primary line. So please take note na naka-PPA tayo dito per phase basis, ha. So phase A pa lang ito, may phase B pa, saka phase C. But if you're considering single line diagram, we only considering here one phase of the system. And then from here, no, you have your three-phase main feeder. Yan na po yung section ninyo. And then, mapapansin nyo rin dito, may recloser at saka may sectionalizer switches. Ayan. At saka may fuses. May fuse yan. Ayan, yung fuse cutout. The question is, what is this fuse? Circuit breaker, no? Main circuit breaker from the topmost part, your sectionalizer, and your reclosers. These are the primary parts or protection parts of a distribution network, no? Yan, yung pababa na from primary to secondary. Ito na yung mga secondary na sinasabi niya. This is your primary, definitely. This is the primary that we have discussed, no? Primary feeder that we have discussed from the last slide. Now the question is, what are the functions and how can you categorize this one or coordinate this one if there's a fault? Okay, so ayan, mga typical na definitions at saka yung mga simple terms for protection. So we can discuss that one on the next few slides. So we can clear this one, but we will go to this again, no, for the briefing or the summary later. So this is just a typical example na nanggaling dito, ha. Dito, yan, isang part lang yan ng system. This is what I am talking about. Okay, then this is the secondary. Then meron kang main circuit breaker dito. Okay, this is the specific. Now, if you want to know, no, what I'm discussing kanina a little bit on the distribution system here in terms of the protective devices, we can discuss this further, no. So we can have a single line representation, no, of the primary distribution. But in this case, hindi natin na-discuss na may relay doon. Talaga may relay dapat ito, ha? Hindi lang pinakita, no, yung relay. Dapat ganyan ang symbol niyan, and then circuit breaker, from here. Okay? So hindi lang pinakita yung relay, but they are in conjunction with each other. You cannot operate, no, a circuit breaker without intelligence. The circuit breaker serve as your muscles, the relay serve as your main intelligence. So pinoprogram yan in order to coordinate with the other relays upstream. Okay, now we can clear this up. Discuss natin muna, no, yung pagdating sa distribution. Instead of a circuit breaker, we use a recloser and a sectionalizer. And definitely in each lateral, meron kang fuse. Okay, now discuss natin. Here, no, this is a single line distribution, no, of the typical distribution circuit. So definitely your circuit breaker, no, from your this is your utility or grid. You have your relay, no, and then, no, each load, no, coming here, you have a fuse, and then you have, no, from this section, you have your sectionalizer and a recloser. They have different, no, functions dependent on the fault. As you can see, may mga fault akong nilagay dito, but we will discuss them one by one so that you can understand their specific functions. Okay, now let us discuss, no, what is a sectionalizer and recloser. Now, definitely ang fuse, alam niyo na yan sigurado, no? A fuse is an automatic, no, type of protection, lalong-lalo na if that is low voltage. And fuses are said to be ganged, right? So we discussed that one on the H type of a substation, right? Yung fuse doon. And here, no, ang sectionalizer, please take note of the word cannot, they cannot interrupt a fault, no? It only counts, no, the number of times it sees the fault current. Ayan, nakalagay naman dyan, Okay, you cannot, no, interrupt a fault. Parang switch lang siya, sectionalizer switch, to be specific. It only counts, no, the number of times, or in terms of frequency, no? So sabihin natin, frequency 1 saka frequency 2. But typically, dalawang beses dapat nyo makita yung fault bago mag-open. Totally open yung switch na yan. Sees the fault and opens after a preset number while the circuit is said to be de-energized. So meaning, no, ang de-energization will be done by a recloser. So bibilangin ng sectionalizer kung ilang beses nag-reclose o how many times no the recloser recloses. So it depends on frequency. It depends on frequency. If that is 1 time, 2 times, but if you set it 2 times, then the sectionalizer will definitely open no to interrupt no the faulted line. Okay, so it has a limited fault interrupting capability and recloses automatically in a program sequence. So it means no it has no a time no allotted of time of operation no. Typically no the time of operation is 1 millisecond to 2 millisecond. So 1 millisecond means no 1 times 10 negative 3 or 0.001 second no doon siya mag-open and then magre-reclose no in a certain time no dependent what will be no the so-called frequency or number of times that you need to totally open the circuit. So ibig sabihin pag recloser you open and then you reclose after 1 millisecond. Now we will discuss this further no on the single line diagram that we have discussed no from the previous slide. So we can clear this up. So nandito na yung definition. Para mas maganda, we can have it on the single line diagram of the next slide here. Okay, let us have no some simulations lang. No, for example here at fault A. Okay, it should be cleared no by the branch fuse, the lateral fuse here. If a fault occurs at A, the fuse must operate definitely to clear the fault at this lateral. So walang problema pagdating dun sa section na ito. Okay, so please take note if there's a fault downstream at A, it cannot be no sensed by B, C and B here because they have different fault categories. Please take note, naka-radial tayo. If you are persistent and if you're observant no on fault calculations, di ba? Different buses, different sections have different fault currents dependent if that is, that is a loop or radially. But if that is radially, the highest fault will be at the upstream, no? Rather, yeah, at the upstream because the XTH limits, naka-limit lang doon. But if you're going downstream, pababa ng pababa yan dahil yung Thevenin's reactance becomes higher. Okay, now in this case, definitely, if there's a fault at A, the fuse will open or will blown up. Okay, now let us clear this one. Let's move forward at B. Okay, at B naman. If a fault occurs at B, okay, it must be cleared by the sectionalizer. Please take note, the sectionalizer, no, the sectionalizer cannot interrupt any fault. The sectionalizer cannot interrupt a fault. So therefore, no, since it cannot interrupt the fault, ang recloser ang magi-interrupt yan. Okay? So in this case, if there's a fault at B here, the sectionalizer will not open, but the recloser will open. Okay? And then after 1 millisecond, for example, no, for the time operation, the recloser will reclose. And the sectionalizer here will count at F is equal to 1. Please take note, we can assume F is equal to 2 in this case. So F is equal to 1, nabilang na niya no, na nag-reclose ng isang beses. So walang problema. F is equal to 1. But there are two types of fault. Actually, may tinatawag ka na permanent fault and a temporary fault. Please take note, no? Pag sinabi mong temporary, mga transient, mga non-technical losses, may nagpapalipad ng saranggola, then for example, may mga squirrel, no, naglalaro doon sa transmission line, sa distribution line, and what happens is example, na short circuit siya, no? Yan yung may tinatawag nating temporary fault. And please take note, 80 to 85% of the time, if you're considering a distribution network, all faults are temporary, 85% of the time. Yung mga permanent fault, bibihira lang yan, 10 to 15%. Okay, in this case, if that is a temporary fault, and that's why, instead of a circuit breaker and a relay, no, naglalagay sila sectionalizer sa recloser. Because if that is only a temporary fault, no, at na misguided niya, no, as a permanent fault, therefore, the power quality from the downstream, open yan. Laging mag-o-open yung main circuit breaker. If that is, no, kung lahat ginawa mong circuit breaker relay. Kasi, hindi niya ma-distinguish na ano lang pala yun, temporary fault. Hindi siya permanent temporary. Okay, now, for example, you have F is equal to 2, no? The number of times or the frequency, the number of times that kailangan mag-open na yung recloser permanently. Now, that is the first attempt. Then, bigla na namang nagkaroon ulit ng short circuit sa B. So, for example, yung saranggola ba, no? So, ibig sabihin, nakaano siya sa line and then lilipad ulit, tapos babalik. So, nag-short circuit na naman siya ulit. Then, the sectionalizer will not open for the second time because nagbibilang lang siya, no, ng fault. The recloser here, at the second time, the recloser will now open, no? Then, after 1 millisecond, it will now reclose. So, the sectionalizer now is F is equal to 2. So, it means that is F is equal to 2. Kailangan ko nang i-open, no, yung line na ito because you have 2 times na nagkaroon na ng frequency or fault event. Ibig sabihin, ano na siya? Hindi siya permanent, but it is a temporary fault. Now, in this case, the sectionalizer now will open. It will now open. And then, you have your Meralco tracks. Okay? Meralco track to respond whether on this line, on that transmission or distribution line, where the fault occurs. So, aayusin na niya ngayon yan. And thus, no, leaving, no, this section here undisturbed. Right? Kaya nga siya recloser sa sectionalizer. Nagre-reclose yan, talagang ginagawa niyan. But in this case, no, kaya nga siya recloser, nagre-reclose lang siya ng specific program sequence. No? But yung total fault clearing, ginaganap sa recloser, hindi sa sectionalizer. Ha? Kaya in that case, no, now you have your Meralco track going to the section here to see whether kung nasaan yung faulted line. Okay, now let's move forward po, no, to the next few slides. I can clear this up and then move forward na po tayo if the fault occurs at C. Now, definitely, if the fault occurs at C, the recloser trips and recloses as expected, no, dito. Pero hindi mararamdaman, it cannot be, no, sensed by section A and B because this fault, no, is a different thing, no, different po yung magnitude niyan. So, different calculations, no, the magnitude only, no, the circuit breaker relay will sense the fault at its corresponding region. So, kunyari, nandito siya sa C, iba yung fault level niya sa BNA, only at C can sense the fault, no, yung mga devices diyan. So, yung mag-a-act is your recloser. So, in this case, no, the sectionalizer does not see the fault, it does not count. So, it can close and then reclose. Now, in this case, no, ang recloser, magre-reclose yan kapag yan pangalawang beses na nag-open ulit, the main circuit breaker will definitely open. Ito, no, kapag yan pa rin naganap pa rin sa recloser. Kasi open then reclose. And then, if there's a fault again, the circuit breaker must definitely open after the recloser recloses. If that is already F is equal to 2. Or, meaning to say, in other cases, that is a permanent fault. Okay, now if you want to have a more clear view of what I'm talking about here, we have some a little bit of a movie on the next few slides. But let's move forward muna doon sa ibig sabihin ng mga iba pa na feeder automation. May tinatawag ka na RCLS or remote control line switch, RCVR remote control voltage regulator, RCLC remote control line capacitor, and RCLR remote controlled line recloser. Ito ang mga ginagamit natin, no? So from what we have discussed here, naka-ano siya, naka program sequence o kaya minsan you can deal it manually, etc. So yung meron ka namang RCLS, ito yung sectionalizer, ayan, line switch. Okay, the others is more on voltage regulation. But we are talking about what we have discussed, yung recloser saka yung sectionalizer. Ito yung RCLS saka RCLR. Okay, to a more sabihin natin yung practical, hopefully you can see this one, so this is a example I from my OJT student, so from here much better, much practical na makikita natin how our recloser and sectionalizer works. So hopefully, ayan. So at first, he needs to know the status, yung main control center. Yung nagko-control lahat ng mga reclosers dito sa kanong mga sectionalizers. So as you can see here, the red ones are yan po naka-close, ito naka-open. Okay, normally open yan. As you can see, there are reclosers from different sections of this power line. Okay, let's move forward. Tinignan nyo muna yung status kung open or closed. So second na status check. Okay. So yun, bumalik ulit sa main control center, then he check that is normally open or normally closed. Okay, so medyo realistic, So you can see there's a parating, na typhoon disturbance. As you can see, it reaches this line. So there's a lightning, that struck, at this line here. I could say line 1 and 2. Okay, so definitely, what will happen, it will, bumagsak itong poste dito. Okay, leaving behind a disturbance. So, nandyan sa section na yan. Please take note, a power system, a very, very big power system. So, you cannot know where its specific location until it reaches the MCC. Okay. So, tinignan niya rito, yung status, nag-open. Okay, now, as I have mentioned, you have some switches here. Binibilang niya, kung ilang beses nag-reclose yung recloser. So, that is 1, Okay? F is equal to 1 from this line. Okay, that's the first tripping. And then, as expected, recloser, it will reclose after sometimes 1 millisecond. So, dapat. Okay. Now, it is reclosed. Okay, now, that's the first recloser, F is equal to 1. Okay, second, still, the system is down. So, mapapansin yan dahil there is a one line here, that is being towed down by the lightning strike. So, yan po, yung lightning. Babasahin na naman niya for the second time, the switches will not open. So that is the second tripping for unlock out. So ibig sabihin, may mga switches diyan that you need to open so that that line will be separated. Ibig sabihin will be isolated. So yung main control center will check the status of the breakers. Then there is an isolation now or power restoration from the master section. Isolation now is in progress because naka-F is equal to 2 na from the second tripping. Ayan, napansin niya na nandito yung section. Now, it will now open. Okay? So you need to open the RCLS, yung switch na ito. As discussed, that is your sectionalizer so that we can isolate this line. So open siya. As you can see here, if this is open, ito lang madi-disturb. But the other parts of the power system, no, you still have power. But you need to, no, close this switch so that this section here will still operable or still operating. So yeah, you need to reclose the switch so that from this area, tuloy-tuloy pa rin, and the only system that is isolated is that region. So yes, you can see that's the operation, the practical ones that I'm talking about, no, on operations and protection. So again, no, based no from the what we have discussed on fuses, sectionalizer, and recloser, this is how it is done practically using a master server and automated siya, no? Syempre, it must be intelligent, right? So to see the status of every switches and reclosers on the distribution network. Okay, we can clear this up. So tingnan natin kung may susunod pa. Okay, balik na siya ulit. The closure is already successful. As you can see, no, those are the lines that is operable, and we already isolate the section we're in kung saan nagkaroon ng failure. So, kung saan bumagsak yung poste, no, ng Meralco, no, for this example. So the fault is isolated and the power is restored with a good power quality and reliability, right? Okay, I think that will be enough, no, for our discussion for tonight. Okay, I will now stop the recording. Thank you very much.